Okay, today we're going to graph linear equations, okay? So, first of all, linear equations, guess what kind of graph you get when you graph a linear equation? Very good. Do you see line in linear? Okay, so linear equation is an equation whose graph is a line.
Should we write that down?
Okay. If you like, yeah, sure. And there are three forms that we're going to be talking about in this chapter. As you will learn, linear equation can be written in different forms. So we're going to learn two today and the other one tomorrow. Okay, the two forms that we'll learn today are the standard form and the slope-intercept form. And the one that we'll learn tomorrow is the point-slope form. We're not going to prove standard form. It's actually a theorem. And then slope-intercept form we will prove. Okay, so that's what we're going to be doing. Any question? Okay. So go ahead, write it down. I'll wait if you like to write. So some of you may remember standard form of a linear equation. It's a theorem. Anybody know what the standard form of a linear equation look like? Yes, sir. How about Kevin?
Y equals mx plus
Okay, y equals mx plus b is actually the slope-intercept form, right? We like that one a lot. That's easy to graph, right? Because with the slope and the y-intercept, we know how to graph. Did we do that before? Okay. For standard form, anybody remember? Yes. You want to try it again? Not quite. No. Yes, sir.
a squared.
Linear equation, it would be x to the first power. So, yeah, almost. But you kind of got close. Yeah.
M equals ax plus by.
No, what is that? Okay, let me just tell you. It is ax plus by equals c. I think a lot of you saw this one. Okay. Yeah, you said m. There is no m. Okay, so the graph of any equation that can be written in this form, ax plus by equals to c, where a, b, c are not both 0. Because if a and b are both 0, then you get 0 equals to some number. That doesn't give you anything. So is our line. Okay, so can a be 0 though by itself? When b isn't? Yes. When a is 0, guess what kind of line you get?
Horizontal.
You get y equals to some number, so you get a horizontal. When b is equals 0, guess what kind of line you get? Yeah, you get a vertical line because you get, you get ax equals some number, divide both sides by a, you get x equals something, you get a vertical line. Okay, so anyway, so write that down. So there's an advantage of using standard form because somebody read this for us. How about Andrew? Go ahead.
The advantage of the standard form is that it's easy to determine the points where the line crosses the x-axis and the y-axis.
Yeah, so it turns out if you have a linear equation in standard form, it's really easy to figure out the x-intercept and the y-intercept. That's what those are, right? The point where the line crosses the x-axis and y-axis, right? The line where the line crosses the x-axis is called the x-intercept. The point where the line crosses the y-intercept is called the y-axis is called the y-intercept. Which letter do we use for the y-intercept? B. So guess what? Which letter we use for the x-intercept? A. So we use A for the x-intercept and B for the y-intercept. Okay? When we're talking about this linear equation. Not capital. Yeah. So capital A, B, C are for the standard form. We use the small letter. Okay. So keep that in mind, and let's think about why this is true. Okay. So we have our graph paper here, graphing calculator. So let's somebody give me a linear equation in standard form. Let's see why it's easy to figure out the x-intercept and y-intercept from the linear standard form. Somebody, yes. How about Jonathan? 7x plus 5y, right? Because it's ax plus by. So a and b are some number. Equals to some number. Which one do you want? 10? Okay, sure. 10. There you go. All right. So, can I change 7 to 6 just because it will make it a little bit easier, I think? No, it won't. How about if I change 5 to maybe 3? Is that okay? Still, it's not good. How about... No, you know what I'm trying to do?
5.
No, let's make it 4. No, we don't. Okay, Jonathan, you gave me the bad one here. Here, I like this. Okay, so no, it's because even then, I don't like this. Okay, how about 6? How about? I want to make it so that it looks.
It looks awesome.
Yeah, no, what I want to do is I want to make it so. Oh, okay, here. I want to make it so that you can see the x and y-intercept easily. Because if it's like this, yeah, it's like right in between, right? You don't know what that point is exactly on the y-axis. You see? Do you know what the y-intercept is now? No, right? So yeah, so you have to guess. So let me make it. Like, there you go. All right, so we have 2x plus b is now 1. Y equals 4. If we have this, what is your x-intercept?
4.
I mean x-axis. I mean x-intercept on this line. X-intercept is where the line hits the x-axis. 2. It's 2, right? What is the y-intercept? 1. It's 4, right? Not 1. Right? 4. Sorry, I said 1. It's 2 is the x-intercept. 4 is the y-intercept. Okay. Now, why do they say having this in standard form? Let me change b to 1 now, and I don't need that b. Why do they say having standard form allows us to find the x and y-intercept really easily? What do you mean? Well, without graphing it though. They don't say you have to graph it. We're just graphing it to see where it is, but without graphing, how would you know? Well, let me ask you this. Can somebody give me the order pair for the origin?
0, 0.
What about this point here?
0, 1.
0.
Is it 1, 0 or 0, 1? 1, 0. Okay, what about this?
2, 0.
Okay, so 2, 0. And so that's your where the x-intercept is, right? 2, 0. And x-intercept is 2. The order pair is 2, 0. So what do you know about every point on the x-axis? What is always true?
0.
0 for y, right? Y coordinate must be 0. Why? Because in order for the point to be on a y-axis, or on the y-axis, I mean on the x-axis, right? Doesn't the y coordinate have to be 0? The height has to be 0 to be on the x-axis. Does that make sense?
Yeah.
So look what happens if I plug in y equals to 0. You get 2x plus 0 equals to 4, and solve for x. What do you get? And isn't that the x-intercept? Okay. So let me, okay, every point on the x-axis, you know that y is always 0, right?
Yeah.
So why not plug in y equals to 0 in this standard form and solve for x? What do you get when you do this? You get x equals to 2. So you get 2 comma 0, right? Which is the x-intercept. Can we do the same thing for the y-intercept?
Yes.
So look at every point on the y-axis. Okay, so first of all, origin is 0, 0, right? What is this point right up here?
0, 1.
0, 1. What is it? What about this? Here? Here? What do you guys notice about every point on the y-axis? X coordinate is always 0. And it makes sense. Otherwise, it could be, it can be on the left or right side of the x-axis, right? Then it won't be on the x-axis. So x coordinate has to be 0 to be on the x-axis, right? I mean, be on the y-axis. So x coordinate has to be 0 to be on the y-axis. So therefore, when I plug in then x equals to 0 here, what do you get? Y equals to 4. That's your y-intercept. So when you have the standard form, it's easy to figure out your x-intercept and the y-intercept. Let me summarize this for you, and they do that for us. So look at what it says here. The line that intersects the x-axis at the point a comma 0, okay? I mean, if a line intersects the x-axis at the point a0, then the x-intercept is a. If it intersects the y-axis at point 0b, then the y-intercept is b. And do you see where they get these zeros for the x-intercept? For the x-intercept, what has to be 0?
The origin.
The y-coordinate has to be 0. What about the x-intercept? What has to be 0 for the x-intercept? X-coordinate has to be 0. Does that make sense? Let's do some examples, okay? So, here. Now, they tell us to graph this line 2x minus 3y equals 12. Well, in order to graph a line, at least how many points do you need? 2. And we just learned how to find 2 points. Namely what? X-intercept and the y-intercept. And so if I have this, look at this equation. This is in what form? Standard form. So to find the x-intercept, what do we plug in for y?
0.
So I'm going to actually call it a comma 0. Because after all, aren't we using small letter a for the x-intercept anyway?
Yeah.
So I'm going to, for x-intercept, I'm going to say, okay, you plug in a for x, 0 for y, then you get your x-intercept. What about for the y-intercept?
Plug in 0 for x.
Plug in 0 for x, and which letter should I use for the unknown? B, because we use small letter b for the y-intercept. So once you do this, you can find the 2 points, right? The x-intercept and the y-intercept. Okay, so let's find the x-intercepts together, and I'll help you do the y-intercept yourself. Here we go. So we have this equation, 2x minus 3y equals 12. So let's find the x-intercept. What are we going to plug in for x? X, are we going to plug in 0 for x? Yeah, to find the x-intercept, you plug in a for x, right? And 0 for y. And once you do this, you get 2a minus 0 equals 12, which is just 2a equals 12. What is your a?
6.
In other words, your x-intercept is 6. What is the order pair that you get then?
6.
Yeah, does that make sense? Do the same thing for the y-intercept here. Go ahead, everybody try. I'll wait. So, who can tell me what we do here? What do we plug in for x for y-intercept? Good. What about for y? B. Because remember, that's the letter that we use for the y-intercept. And of course, you get 0 minus 3b equals 12. So the answer is? What is the order pair?
0, -4.
Do you know how to graph this 9 now?
Yes.
Go ahead, everybody try. I'll wait. I'll graph it also. So let's plot the x-intercept and y-intercept. So we got x-intercept is what? Where is it? 6. So it's going to be on the x-axis right here, 6. And the y-intercept at -4. There you go. And so all you have to do is what? Connect. Okay. Connect them together. We know it's going to be a line. It's in standard form. There you go. Okay. Any question? Now, what does this line represent, by the way, in terms of this equation? 2x minus 3y equals 12. What is this line made up of?
Points.
Yeah, infinitely many points, right? That are right next to each other like this. Now, what does it represent? 2 people? I want you to discuss with your group. This is important. What does this line represent, guys? All right, who thinks they know what this line represents? Okay, Samantha, what do you think?
It represents all the answers to the equation.
Good. Nicholas, did you want to add something to that? No? Okay. What does she mean by it represents all the answers, Nicholas?
It represents all the many different values of x and y that will fit the equation.
Exactly. If you were to choose any point on this line, right, and you plug into this equation, would this equation be true?
Yes.
Yeah, left side will equal to the right side, right? Because how many solutions are there for this equation? Infinitely many. Does it mean you can plug in any points on this x and y axis? No. But every point on this line, right, will represent, right? Every point it represents a solution. So could you write down all these order pairs that makes this equation true? No, it's impossible. There are infinitely many of them. That's why we graph them, right? Because this graph, more precisely, every point in this graph are solutions to this equation. And of course, it extends forever to towards direction. Does that make sense? Do you see what this line represents? This graph represents all the solutions to this equation. Okay, you choose any point on this line, plug it in, the left side will equal to the right side. Right? Does that make sense? All right. So knowing this, let's try the second example. Second equation says, find the point of intersection of 2 lines. One line is x plus y equals 6. The other is x minus y equals 2. How do we find the point of intersection? By the way, what do they mean by this? Point of intersection is basically where the 2 lines intersect. And when the 2 lines intersect, right? When we say 2 lines, we mean 2 different lines, right? When the 2 lines intersect, as long as 2 lines are not parallel, they will intersect, wouldn't they?
Yes.
When the 2 lines intersect, what does the intersection look like? It's a point. It's a point. So how would you figure this out? Well, could you graph it? Yeah. You could always graph these 2 lines and figure out where they intersect, but graphing may not always work because when the 2 lines intersect, do they have to intersect at that right where the grid is? No. Then you can't really figure out. If it's not, then you can't really figure out exactly what those points are. Not only that, it could be outside of your graph paper, right? So then you can't figure out. So what's the nice way to do this? You use the algebraic method. Does anybody remember how to solve this? You guys remember solving systems of linear equations?
No.
There were many ways of doing it. One of them was to use substitution method. The other was to, which was easier, adding method. Remember, you could add both of these equations together, hoping that what? When you add the 2 equations, you have to have what?
One variable.
Yeah, one variable cancel out, right? Does one of the variable cancel out? Yes. Thankfully, it does. So look, when we add these together, we get 2x what? Equals to 8. Because the y's cancel out, right? So then, of course, 8 equals to? Now, does this mean, am I done here? No, this is only one coordinate of the x-axis, right? I mean, one order pair. One of the coordinate of the order pair. We need the other one. How do we figure out the y coordinate? Brianna? Yes, you plug into where? One of the equation. Does it matter which one? No. Why not? You're right. It does not matter which equation you plug in because when you think about it, when the two lines intersect, and the intersection is solution for both of them. Does that make sense? So it doesn't matter which one you plug in, right? Because that's the only point when you think about it. That point where they intersect is the only point where it will be solution for both of these. So let's plug into any one of them. I chose to plug in x plus y equals 6. It doesn't really matter. And when you plug it in, you get x equals 4. You get y equals 2. 2. So now you have your solution. 4 comma 2. That is where the two lines intersect. Does that make sense?
Or you could just do the same thing with y, right?
Yes, you could have solved for y. What do you mean? 7 for y.
Like just subtract x. X and x.
Yeah, so you could. I like adding both things together. Yeah, so there was a subtraction method, but when you start subtracting, you may make silly mistakes. So make sure you try to do add. You try to add. Okay. And so that's how you do that. Let's see whether this is true. Let's graph it and see if we get the intersection at 4, 2. Let's verify. Okay. Here we go. Okay, so can somebody give me those equations? Let's graph those two. Yes, Nicholas?
X plus y equals 6.
X plus y equals to 6. There it is.
And x minus y equals 2.
X minus y equals to 2.
Yes.
And do they intersect at 4, 2?
Yes.
Yes, it surely does, right? Do you see? But this is nice, but like if it was 2.3, you see how it's not really nice? You don't know exactly what that point is. That's why graphing method, although you could kind of see it's nice, sometimes you cannot get the precise solution unless you do it algebraically the way we did it, okay? Does that make sense? Let's put it back to 2. Okay, any questions? Now let's try one more. They give you two lines again. 5x plus 3y equals 21. 2x plus 2y equals to 10. So,
Subtraction method.
No, I don't like you to subtract it. Even if you subtract, it doesn't really help you. So, okay, I could write it. What's the problem here? Okay, I could write it vertically. What's the problem here, guys? I could add or subtract. Yeah, they don't cancel out. I don't get rid of one of the variable. And I don't like to subtract. See, you make silly mistakes. So, what do we do?
Substitution, you just get y equals.
Okay, you could use substitution method, but there is a trick that you could do so that one of the variable cancel out. How about, Amy, what should I do?
So, multiply both sides by a number that makes
Yes, okay, so, yeah, it's kind of like finding the common denominator of a fraction, isn't it? Like, let's get rid of the y's. How can I get rid of the y's? Well, it's 3y and 2y. What is a common, like, yes, if I make both of them 6, wouldn't they cancel out?
No, we can multiply the top one by 2.
Yeah, so why not multiply the top one by 2, and then bottom one by?
-2.
Not 3, but negative 3, because then I want to add to get rid of it. Does that, you guys remember this trick?
Yeah.
Okay, go ahead, everybody figure it out. I'll wait. What do we get when we do this, okay? So, did you all get, when you multiply the top equation by 2, of course you got to multiply both sides, and then bottom one by negative 3, did you get 10x plus 6y equals 42?
Yeah.
And then negative 6x plus negative 6y equals to negative 30? And of course, when you add now, the y's cancel out, don't they? So what do we get here? We get 4x equals 12, x equals to 3. Of course, you could plug this x to any original equation. When you do, I chose the 2x plus 2y equals 10. Y equals 2. 2, so there you go. You get the order pair 3, 2. That's where the two lines intersect. You guys remember this? Okay, can you do something like this for your homework tonight?
Yeah.
All right, good. We're not done. We're not done. Here we go. Let's do the last part now. The slope-intercept form, you all know, is a line with equation y equals mx plus b has slope of m and y-intercept of b. This theorem we're going to prove. There are two things to prove in this. First thing is that we have to show that m is the slope of this line and b is the y-intercept. Okay? You all know how to graph using slope-intercept form, right? You first plot the y-intercept and use the slope, right, to find the other point and right connect them together. We did this before, but we haven't proved this. So let's prove this thing. Okay, so write that down. Let's prove why the m is the slope if you have this form, and the b is the y-intercept. Okay. So first of all, I know this is not part of the theorem, but we know that. How do we know this is a line, guys?
Slope and y-intercept form.
No, we know this is a line because you could rewrite this as a what form? Standard form. Okay, it's not part of the theorem, but I just wanted you to know. You could write this as a standard form, right? Or you could write standard form into a slope-intercept form. Right? Your a is -1. I mean -1 negative m, your b is 1, and your c is small letter b. Right? Now, we have to show that m is the slope and b is the y-intercept. Let's just show that b is the y-intercept first, because that's easier to do. How do I show that b is the y-intercept? Well, what do you know about every point on the y-axis?
It's X.
X coordinate is always 0. So why not just plug in 0 to this equation and find out what your y-intercept is? Do you get, when you plug in x equals 0, don't we get y equals to b? Right? So therefore you get 0 comma b. What is that? B is your y-intercept. Very easy. So that part is easy. What's the second part we got to show? That m is the slope. Well, how do you show, well, how do you find the slope of a line? You need how many points?
2.
You need 2 points. We have 1 point right here, 0b. Right? What's another point? Well, plug in x equals to, what's the easiest number you can plug in?
0.
Well, we already plug in x equals 0. So you could plug in y equals 0. Turns out you could plug in x equals to 1 and be a little bit easier. So yeah, you could plug in y equals 0 too, but then let's just plug in x equals to 1. When I do, don't I just get, let's just plug in x equals, y equals to 1. So there's my first point. When you plug in x equals to 1, you get y equals what? M plus b, don't you? Isn't that what you get when you plug in x equals 1? So you have 2 points, 0b and 1 comma m plus b. Yes? Now, all you have to do is use the,
Standard form.
no, how do you find the slope when you have 2 points, guys? Just use the, yeah, y, this formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And I even labeled that for you. Go ahead, everybody, go ahead and find out the slope and see what you get when you find, on these 2 points, 2 points of this line, y equals mx plus b. Yes? Go ahead and find the slope. I'll wait. Go ahead. When you plug in, don't we just get m? And isn't that what we wanted to prove? Because you get m plus b minus b over 1 minus 0, right? So we just get m. And so, using 2 points of this line, y equals mx plus b, the slope is m. That's how you show that the m has to be the slope. Does that make sense? So we have proven those 2 parts, that b is the y-intercept and m is the slope. Does that make sense? Okay, any questions? And can you graph a line using slope-intercept form? Okay, let's do this real quick then. Here we go. So if they ask you to graph 2y equals to x minus 8 using slope-intercept form, what is your slope? Yeah, it's not 1, is it? What do you have to do first, guys? They kind of got a little bit creative. What should you do first? Yeah, you got to divide both sides by 2 first. Then you know your slope. What's your slope now? Yeah, you have to have y equals mx plus b. It has to be in that form, right? You can't have 2y. So yeah, slope is half. The slope is -4. And of course, where do you start? At -4. Your slope is 1 over 2. You go up 1 to the right 2. And you connect. You could go down 1 to the left 2. Could you do that? Because that's -1 over -2. Same thing, right? So I got 3 points and there it is. Easy enough? Can you do something like this for your homework tonight? Any questions? Good.